Right, the function f has domain 0, infinity, and is defined by f of x equals square root of x plus 1. Find an expression for the inverse function of f of x, so f to the minus 1 of x we want here. Okay, so we want here, so we've got f of x equals the root of x plus 1. We write this as y equals the root of x plus 1. Okay, and then, of course, we want to get x in terms of y, so we'll just square it. When we take the square root over and we square, okay, so we'll have y squared is x plus 1. Then we take the 1 over, so we'll have y squared minus 1 equals x. And we're done. Okay, that's it. Right, nothing more to do. Okay, so f to the minus 1 of x is x squared minus 1. So we've answered part A. Part B then says write down the range and domain of f to the minus 1. Okay, so of course we know the domain of f, okay, but what we don't know is the range. Now we're going to need to work out the range of f first, right? So before we even tackle this, before we write down the answers to this, we actually need to concentrate on this, don't we? Because remember, the domain of f is the same as the range of f to the minus 1, and the range of f is the same as the domain of f to the minus 1. Okay, so if we work out the range here of f, okay, so domain is 0, so put 0 in to here. Okay, so you end up having the square root of 1, which is 1. Put infinity in, so you end up having square root of infinity plus 1, which is just infinity. So the range will be 1, and it'll include 1, because it included 0, and then infinity. Okay, so there's the range of f. So when it comes to f to the minus 1, the domain is equal to the range of f, so that will equal to 1 infinity, and then the range will equal to the domain of f, which will equal to 0 infinity. Part C then says sketch the graph of f to the minus 1 of x, right? Using the same diagram, sketch the graph of y equals f of x. Now when you see that, it's not necessarily so easy to draw, but this one, of course, should be easy to draw, x squared minus 1, okay? And it's important, right, really important, when you draw the inverse function here first, it's important that you take note of the range, right, and domain, sorry. The domain is 1 infinity. Okay, so when we actually draw this, okay, when we draw this, we always have to have in our minds, paying attention, when we're drawing f to the minus 1 of x, I'll write it here so we can see it. When we're drawing this, okay, and we know what x squared minus 1 looks like, quite simply, it's x squared, a smiley face, shifted down 1, yeah? So it's x squared, a smiley face shifted down 1, just to remind you, that's what it is, isn't it? Okay, so the minimum there is minus 1, okay? That's the minimum, at minus 1. But we want to go from 1 infinity, okay? We want to go from 1, sorry, on the x-axis, because that's the domain of it. So we start here at 1. Now the value 1 actually turns out to be 0 in the range, isn't it? When you put 1 in here, you get 0. So the lowest point there is going to be here. So if I drew my curve, it would go through that point. And basically it's going to be, you'd imagine it then keeping going until you get to minus 1 down here. Okay, so you've got minus 1 down here, and it would keep on going. So we go around, and we're going to have our curve then keep increasing like that. Okay, that makes sense, right? It's important that you see that there. As I say, you know x squared minus 1, the inverse function, is x squared shifted down to minus 1. Okay, but we don't need to draw this bit. We shouldn't draw this bit because the domain starts at 1, right? And if you put 1 in here, you get 0 out. So we know when x is 1, y is 0, and you've got your graph. It says then, using the same diagram, sketch y equals this, f of x, so sketch that. Okay, now in order to sketch that, all you've got to do is reflect in the line y equals x. Okay, always to draw the inverse functions, you always draw the line y equals x. Okay, so this is your inverse function. So to draw then the original function f of x, you reflect. Also, all you do, you reflect in the line y equals x. So if you reflect in the line y equals x, if it starts here at 1, it's going to start here at 1 on the y-axis. Okay, so if it starts on 1 on the x, it'll start on 1 on the y. And then you draw your curve so it reflects. Okay, there's your mirror there. So you want a line of symmetry as the mirror. So we're going to go, and what's important is that they do intersect there, where it crosses the mirror, that they do cross at the same point. And then this line sort of shoots, the curve shoots away from the line y equals x. So this curve here should shoot away from the line y equals x as well. So you get that. Okay, and you've got your answer. Okay, and you can label this f of x, and it's job done.